Okay, good morning. Welcome to the next INF 33-31 lecture, INF 34-31. Today you're going to learn bash. And so when I first saw bash, I thought it's maybe quite a bit of an outdated language, which is probably true, but I hope to convince you that in quite some circumstances, it's actually very useful to use bash. And so it's absolute a good toolkit to have on hands. And in particular, when you combine it with other scripting skills, it can be used very, very effectively. But before we start, some organizational things. I hope you've all signed up to GitHub already and signed up to the course by filling out the web form. And I also hope that you also received an invitation for a private repository already. If that has not happened yet, then please talk to me after the lecture and we'll try and sort it out. And so just as a reminder, so you have to use a github.com username. You can't use the uio.github.com. And so what's happening this week? The first group session assignments will be, well, the first group sessions start this week, and you will be working on assignments, specific assignments for the group sessions. And remember, this is optional. So if you feel that you already know Git and it doesn't add any value to you, then feel free to skip it. And, but also you can use these group sessions if you have questions regarding your mandatory assignments. Right? So the group session teachers won't help you to solve them, but they will help you to answer any questions and be as helpful as possible. Then the deadline for the mandatory assignment is this Friday. So make sure that you upload the solutions of the first mandatory assignments into your private GitHub repository by Friday, right? And there's no need to submit anything to Devlery. What we're going to do is we're going to download all your private repositories and then grade them and upload the points on Devlery. So you will see the points on Devlery at the end of this week. Yeah. So make sure that you push your solutions into that repository. Right? So please don't make your own repository and publish it to a public repository, because then the point is that you can't see each other's solution.
The repository is private, right?
Yeah. So it's only visible for you. And so something maybe just general about the mandatory assignments. So you're more than welcome to help each other on the mandatory assignments, either be it privately or on Piazza, so answering quick technical issues and so on and so forth. But there's a limit, right? So you're supposed to solve these mandatory assignments by yourself, because they get graded and they go into your final into the pass and fail. So, so definitely what you cannot do in any case is to just copy and paste solutions or parts of solution be it on Piazza privately and use them in your own solutions. Right? You have to come up with your own solution, but you can get inspired and get help by other people. So the assignment 2 starts, this is going to be published today. So I think I just published it after the lecture. And this second mandatory assignment will be on bash, which we're going to learn today. And so from now on, you'll always have deadlines from Tuesday to Tuesday. So it was only the first week where I gave you kind of from Tuesday to Friday, but from now on, it's always going to be exactly 1 week. So Tuesday to Tuesday. And then also, I'm also going to publish the group assignment for next week, which will always also be about bash. Right? And so today, it's all about bash scripting. Any questions regarding assignments or group sessions? No? Good. Okay, on to our main topic, bash programming. So to start off with, I want to give you an overview of the different shells that you have available in Unix systems. So bash is really a concept that was introduced in the Unix systems. And so originally, scripting languages were actually just extension of command line interpreters that you would find in these Unix shells. And one of the major shells that was used in practice was it's called the Bourne shell. And the command was just sh. And you'll actually still find this command in your Mac or in your Ubuntu system or Linux system. And then it was extended to the more powerful C and Tickle shells. So CSH and TCSH, they are not installed by default anymore, but you can install them if you want on your favorite system. And then after some time, there was the Born Again shell developed. And that's the one, it's essentially an improvement of the original Born shell. And that's the one that you will still find on most Linux and Mac systems today. And then, of course, there have been various derivatives of that one, like the Dash shell, the Corn shell, and the Set shell. And all of them have kind of their own flavors. And you might, maybe one day, I never switch to a different one, but maybe you prefer one of these flavors for your own things. But today, we're going to mostly focus about Bash. Yeah. So of course, you might want to ask, why should I learn Bash in the first place? And so first of all, if you want to learn Unix, then really learning Bash is one of the key components. And it also means that it's really kind of the root where scripting came from. Right? So we're going to learn the essentials of the history of scripting. Another reason is why it's really useful to know some Bash scripting is because you'll actually find it over and over again when you read other people's code, if you read programs that are installed in the systems. They're very often Bash scripts. So it's really useful to kind of have an idea of what the script might be doing.
Bash is also available on Windows now.
Right. So with this Windows subsystem, you also have Bash on Windows. Yeah, and so finally, Bash is really, if you have simple certain tasks, Bash is widely available on essentially all systems. So it's a really useful scripting languages to get started. Widely available. Now, from a practical perspective, when is it useful to use Bash scripts? So they're really good if you want to glue together existing programs. For instance, maybe you've scripted some advanced Perl scripts and Python scripts, and now you want them to interact with each other. Then you can use the shell script for that. And when you develop shell scripts, there's quite a common pattern evolving. So typically you start off with just, you open up your command line and you type in some Bash commands that kind of do the job that you want. It's a sequence of commands. But first of all, you typically just type them in by hands, right? The commands that you want to have executed. And then, because you have to maybe execute them multiple times, you save them in a file and you get a small Bash script. But then sometimes you want to call the script slightly differently, so you start introducing some command line options to be able to configure your Bash script. Then maybe you want to do some error handling, so you introduce some if tests, maybe some loops over files if you want to operate on multiple files. And at some point, your script becomes so big that it's maybe not manageable anymore. And then you go ahead and port this functionality to another scripting language, for instance, Python. So today, all the scripts that I'm going to show you will run under the Bash shell, and many of them also under the original Bourne shell. And so just for you to be aware, I mentioned that there's differences between the operating systems. So this command /bin/sh, which originally was the Bourne shell, nowadays points to different shells at different operating systems. So if you're on Mac, then bin/sh is just a link to the Bash shell. If you on Ubuntu, it actually links to the Dash shell, which is kind of a minimal version of the bash, which is often compatible, but not always. And then on Windows, you get bash either through the Cygwin or through the Linux subsystem in Windows 10. But if you want to make sure that you run a command using bash, then it's best to explicitly say /bin/bash. You'll see that in a second. So here's some reference material if you want to. There's the bash reference manual, which is kind of an extensive list of the bash, and then a more user-friendly bash scripting guide on this link. But many of the tasks are best solved by just learning by doing and actually Googling or using man pages when you have questions. So specifically, what is bash good for? When should you use bash scripting? So first, if you do have to do a lot of file management and directory management, or if you want to build some build scripts, maybe some compilation scripts, shell scripts are often used. Then, as I mentioned, if you want to combine multiple existing commands, it's useful. And then for kind of rapid prototyping, if you just try to quickly test something out before you move on to a more advanced programming language. And it can also be used for kind of very simple output processing plotting, but you will reach the limits very, very quickly. So that brings us to the point when you should not use bash. First of all, if you want to have cross-form portability, so as long as you know that the bash script is installed, then it's fine. But there's also the problem, for instance, that different operating systems handle file names differently. So think about Windows uses a backslash to separate directories, while Unix systems uses slash, right? And so handling these kind of differences aren't really supported by bash. And so very quickly you end up in a huge mess of constantly having to check on which system you're on.
If you use Cygwin, then you will use the // for file name.
Okay. Yeah, good point. So of course, if you're in the Windows subsystem, then actually the subsystem converts these file names for you. Yeah, good point. So then, if you want to do more advanced graphics and graphical user interfaces, there's very limited support. If you want to use more advanced libraries, more advanced processing and plotting, and more advanced calculations like maths, it's best to move on to something more advanced. So here's some common tasks that you might want to do. So maybe you want to write some files. You want to execute some for loops. Maybe you want to loop over a bunch of files that you want to operate on. Maybe you want to run one application or combine multiple applications. Maybe you want to test. Maybe you want to perform an operation based on some file testing, right? So maybe you want to check if something is a directory or file or executable or not. Maybe you want to manage files. So for instance, when I handle your assignments, right? So I use bash scripts for that. I download all your assignments and then I kind of run a bash script to check that you've created the correct directories and so on and so forth, right? So this typical file management. Then if you want to perform operations on an entire directory tree, for instance, right? Maybe you want to, rename files that have backup files or so and move them into a different directory. That's a typical bash script. And then if you want to pack directories together, maybe you want to send an email containing an entire directory tree. Okay, that gave you a bit of an overview of what you can do or what you can't do. Now let's get started. Here's your first bash script. Consists of 3 lines where one of the lines is empty. And essentially, what you need to know, so the first line here is a magic line which tells the shell which shell interpreter to use, right? And so here I specifically specify that I want to use /bin/bash. So I want to have this script executed with the bash shell. The way you do it, so this magic line always has to start with the colon, with the semicolon and the explanation mark, and then the command line interpreter. Right, and then after that, you just have a list of bash commands. In this case, I use the echo command, which prints something to file, and then here's this hash can be used to add comments. Okay. So why is this not working? So normally I can execute these lines. That's something else. Let's try this again. There we go. Okay, so when I run this, down here you see the command output. So it just says hello world. Not so exciting for now. So how do you run this? So here I can run it on the slides, but how do you run this on your computer? So, well, one way is that you actually type this echo command directly in your command shell, and then you get the output immediately once you press return. The alternative is that you save these 3 lines in a file, for instance, helloworld.sh. So the sh extension is often used for shell scripts. And then what you need to do is you make this script executable. So you set a flag to the file saying that it's executable. So this is this chmod, change mod command. And this a+x means I want to add the executable flag to the file helloworld.sh. And then after you've done that, you can type in /, just indicating in my current directory, helloworld.sh. Press return, and then it will be executed. And you'll see the hello world output. And it's in this last line, helloworld.sh, when you call this, this is where this magic first line is being interpreted, because the system needs to know which interpreter should be used to execute this file. You see? So let's make the script a little bit more advanced. This time we add, it's the same output that we get, but we started using a variable. Variables are just introduced by the variable name on the left, and then equal, and then the value on the right-hand side. So this is how you create variables, and then if you want to use variables again, you need to use the $, and then curly brackets with the variable name inside. So this is called variable substitution. So in here, for instance, I substitute the variable name x into the string that I output. So keep in mind that the syntax is also valid if you don't use these curly brackets. But this works in most cases, but in some cases it doesn't work. So for instance, if you wanted to print out hello worlds here with an s at the end, and now if I remove these curly brackets, you can already see that bash is interpreting the variable name as xs, right? Which is going to be not existent. So here I really need to use these curly brackets to indicate that it's only x that's the variable name, and the s is just another character that comes behind that I want to print out. So in even more advanced bash script, this time we again have a variable that we want to print out, but this time we get the value of the variable by executing another program and storing the output of that program into that variable. So what you see here is x equals, and then I use these left-hand side semicolons or whatever they're called. And inside there, I have a shell command that I want to execute. In this case, it's the date shell command with some command line arguments here. And so I execute that, and I store the output in the variable x, and that's what I then print out. And so it turns out this command here actually returns the today's day of the week. So if I run this, I get hello world, check. And again, which is very often the case in Bash, you actually have multiple syntaxes for the same thing, just because of historical reasons. So alternatively, instead of these semicolons, you can use x equals $normal bracket state. So that will then be interpreted as a command and executed. So here's a quiz for you. I have a very simple, what I thought is a variable assignment, but if I execute it, I get this error message. Any clues why this doesn't work? Yeah?
Space.
Yes. So it's the spaces in between. So if you do, so this is something that you will encounter quite often in Bash scripting, is very fussy about you need to have some spaces there or have no spaces there, and otherwise you get errors. So if you do this, it'll work just fine, but as soon as you add spaces, the way Bash interprets this is that it thinks you're trying to run the command X with the command line arguments equals and 5. Right? Yeah, so you have to be aware of that.
And actually, both those spaces are problematic. If the first space, if you remove the first space but keep the second space, it will assign a variable to empty string and then try to run the command 5.
Right. Yes. So just to take a home message, do not use spaces when you do variable assignments, both before and after the equal sign. Now, if you want to do some simple mathematics in a shell script, you can use the following notation. Use a dollar and then a double brackets. And inside that, you can add an expression. And that will then evaluate the mathematical expression and return the result. So for instance, if you want to just increment or just add 1 to an existing variable, so we have x equals 5, and then we want to compute x plus 1. Right? So that's how you do it. You just write x equals 1. So you see you can do variable substitution also in these expressions. And then if you execute this, you get 6 equals 6. But very quickly, you will get the limitations of this. So if you want to compute the sinus or the cosinus or tan h or whatever, you will realize that this won't work. And then you have to move on to a more advanced calculator. For instance, there's something called BC in Bash. This is kind of, I think it's the Bash calculator maybe, which essentially can be used for more advanced calculations. But if you have a counter and you just want to count up a variable, then this is very useful. So one thing to be aware of, last time we talked about this typed languages and untyped languages. So in Bash, by default, variables are untyped, which means that if you have a variable x equals 5, and then you think, well, let's just add 5. Let's just add another 5 to this variable x. Right? So I write x equals x plus 5. And then I try to print this out. Right, so what you get is, well, so that actually doesn't make any sense, right? So I need to do this. Right, so I want to add the value of x plus 5, and then I print out the value. But what it does is it interprets the 5 as a string, and so the output is 5 plus 5, not 10. So in this case, I would need to do these arithmetic expressions that I've used before, for instance. But the point here is that I don't need to declare, but if I don't need necessarily to declare types in Bash, and if I don't, then you get an untyped variable. But you can, optionally, you can specify types in Bash. So for instance, here in the first line, I create a new variable. I create the variable x, and I declare it to be an integer. So this minus I specifies that my variable should be an integer in the future. And so now,
The dollar again?
yes. And so now, the same program as before will now return 10, because I specifically said that x is a integer, so it will be handled as an integer also in the future. And so the interesting thing is that this also holds for future variable assignments. So if I now say x equals hello, and I try to print it out, the output will actually be 0. Because hello is not a valid integer value, so it will just reset it to 0, and you'll get the value 0 out. Okay, so once you've specified that a variable is an integer, it will remain an integer, which can be quite useful, right, to make sure that you never end up with a string in a variable that you think should be a integer. Another thing where this can be useful is if you have variables that should only be read, and you should not be able to change its value. So this you say you do declare minus r equals declare minus r makes it a variable, a read-only variable. And you set it once, so you set it to r equals 10, and then if you try to set it again, you get an error message saying r is a read-only variable. You're not allowed to change it. And then there's another declare minus a if you want to create arrays. If statements are often useful, and this is how here's the syntax of them. So essentially, here we're doing a string comparison of a variable called name and the string Irvin. And then if that's true, right, if these two strings are equal, then I print out to header Irvin. So here again, you have to be quite careful with the spaces that you use. And so one mistake that I often make is that I forget the spaces between the spaces here and here. So make sure that you use spaces before these comparison operators. Otherwise, you end up with not very useful error messages. There's something else that you need to be aware of. So you might be wondering, why did I use these double colons here around the variable? And the reason is that I essentially want to make sure that I convert this variable into a string, and I use these double colons for that. Because this is specifically a string this is the syntax of this string comparison. So if this variable name was already a string, then I wouldn't have needed these colons. But in case name is an integer, right, then these double semicolons convert that integer into string, and this string comparison will be successful.
It's also useful if name is not set, because then it will just be equal and a string.
Good point. So if name is not even set, right, then this conversion will also succeed, and the if statement will not fail. So the reason why this is important is because there's another way of comparing specifically integers. So if you want to do an integer comparison, you use the syntax down here. So you use the variable, but here you need to make sure that you need to be certain that variable is actually an integer. And then here minus equal, so here you compare for equality with the value 10. So this is sometimes useful if you want to check for equality, right? I mean, you could have also used the string comparison, but for instance, if you want to check if something is larger or smaller, right, then integer comparison can be useful. But as a kind of take-away message, essentially try to use string comparison is the more safe thing to use, unless you really know that you're handling integers. Then you can use the integer comparison. So here's an example where kind of a safe and maybe an unsafe version of the same comparison. So here I use a variable, this dollar question mark, which is a special variable, where I might be not certain if it's an integer or not. And so then the first version, I do an explicit conversion, and so I end up with the safe comparison, while down here, it might not be safe. Right. Next thing are command line arguments. So command line arguments are very, very often used in bash scripts to configure how the script should behave. So for instance, this ls command lists the directories in a file, and the files in a directory. And so essentially you can just run it with ls, and it will list it in the default behavior. And then you can use ls minus l, and that will change the formatting of the listing format to show some additional information. Or you can add 2 arguments. You can execute ls minus l and then the directory name, and that will show the content of that subdirectory. So how do you handle these in bash scripts? The way you do this is that bash will give you special variables that you can query. And for the command line arguments, these special variables are the dollar and then a number, and the number represents the position of the command line argument. So $0 will be ls, $1 will be minus l, and $2 will be the inf3331 in this case. So in addition, you can use $at, which will give you all the arguments that are being passed as an array. Or you can use $hash to get the number of command line arguments that have been passed. Here's a simple example that makes use of that. So let's say you want to, so this is a script that reads all your command line arguments and shows one after the other. And the way it works is that the first line just uses this $hash variable to print out how many parameters you have. Then I use a while loop here. So here this is how while loops are done. And then in the comparison, I check if the first command line argument is not equal to the empty string. So essentially, if the first command line is not defined, then this string will, on the left-hand side will be empty, and the right side is empty, and then I cancel the while loop. And as long as the first, this variable is defined and is not empty, then I jump into the time loop, into the while loop. So let's say I have a command line argument, then I print out its value, I print out how many I have left, and then I use the shift command. So what shift does is essentially removes the first command line argument from the command line argument list. So you remove it, and then you end up with a shorter command line argument list, and you just loop until you removed all your command line arguments. So let's try this out. So I've coded up exactly this script here. I called it loop through arguments.sh, and then let's call it with 1, 2, 3, 4 arguments. Let's see what it does. Yes, you start with 4 positional arguments. The first parameter is equal to ls. And then, okay, so, oh yeah, so sorry, this is the very first line. And then here we're inside the loop. So first you get ls and 4 arguments, then you get minus l and 3 arguments, then you get minus h and 2 arguments, and then finally the last one. So here's a tip that is quite convenient if you have a script that doesn't behave as you want it to. What you can do is you can switch on a debugging mode in bash. And the way you do that is you just add -x either in the first line, in this magic line of your script, or you call your script using bash -x and then the bash script. And what that will do is it will, before it executes a line, it will actually print out the content of the line, so the source code of the line, and then it will execute it, right? And so you will see kind of each line and then the execution, and at some point it will stop, and then you can just check the line above and see what went wrong. So here's an example. I have this script backup.sh, which I thought I coded up such that it starts a backup on Tuesdays. So this line here, I have an if statement, where in the condition on the left I have date plus $r, which I hoped would be the today's day. And then I check on the right-hand side if that's Tuesday, and then I start my backup, and otherwise I don't start it. Right? But now if I actually execute this, I think I have to do, oops. Okay, well, let's go here. So I run my backup.sh here, and I get no backup today. So this is not what I expected. Okay, so then what I do is I run it with bash -x. Right, is this big enough? So now you can see the first, now you can see what's going on. In the second line, this is the comparison line in my if statement, right? And so on the right-hand side, it's Tierstark. So this is the string that I've coded up. But on the left-hand side, it's 853. So clearly, my date command was incorrect, and I accidentally extracted the time instead of of today's day. So then what you can do is you check your script again, and you copy out this. Okay, I check what this does. Date plus $r. Okay, it does return me the time and not the day. So then what I do is I run man date. So man opens up the manual of the date command. So here's loads of information about so date prints or sets the system date and time. And so I need to look down here somewhere. And this line tells me I need to use $a to get the full weekday name. And I used $r instead. Okay, so now $a, that was the mistake. So I go back into my backup script, change this to an A, run it, and starting backup. Okay, so now things are as expected. Okay, so this can be quite useful, because otherwise, yeah. Of course, you can also print out variables. That's another way of doing it. Okay, I've got 5 more minutes. Now, the next topic is how we can combine bash commands. And this is really where bash shows its power. And essentially, the way it works is that you pass text between the different bash commands. Right? So one program outputs some text and use the text as an input to the next program. And then you potentially use that program's output for the next program, and so on and so forth. And the reason why this is so powerful is because in Unix, there's this philosophy of the programs doing only one thing. They solve one specific problem, and they solve it really well. And you get the power. So one program itself isn't very powerful because it just solves one small problem. But you get the power by combining all these different pieces to kind of assemble a program that solves your specific problem. So the thing that you need to know when we combine these programs is how a shell process works, or a Unix process. So essentially, the way you have to imagine it is any Unix program takes in some inputs using it's called the stdin stream. So you can send in data into a Unix process. And then it also returns, it also outputs some stuff. And so there's essentially two main channels. There's the standard output that the process writes output to, and there's the standard error channel that the process can write text to. Right? And so essentially, the user input goes into, whenever you type something into a process, it goes into, it comes into through the standard in into the process, and then whenever the process prints something, normal information will be printed out through the standard out, and error information will be printed into the standard error. And then after the process is finished, it will also return a so-called return code. And essentially, this code will be 0 if the command was successful, and another number if not. And you can, sometimes it's useful to check this return code if you want to make sure if a command was successful or not. So I want to give you an example. There's this, I start this command wc minus w. That essentially counts the number of words, I think, that you type in. So I run it, right? And so now the command is waiting for my input. And so essentially I can type something in, and while I'm typing, this information is being sent to the script using the standard in. Right? And then this is the second line. Blah, blah. And once I'm done, I have to press Control D, right? And that cancels kind of that stops the standard in and tells the program that I'm done with my inputs. And then I get this number 9 out. And this is the number of words that so this is what the WC computes the number of words that you've passed into the standard in. And so this number 9 came out of the standard output. So this is in standard output, and by default, this is just printed onto screen. And also if you, for instance, if I want to delete a file that doesn't exist, you get an error message, and that, so cannot remove this file because it doesn't exist. And so this error message came through the standard error channel, and again, by default, this is just being printed to screen. Right? I'll show you in a second how we can redirect all these channels, but this is essentially what's happening. Okay, let's have a break. Let's start again at 1:15.